I'm Joshua Timberman, and I've never been to this meetup, so I'm happy to be here, and thank you for having me. Today I'm going to talk about simplifying container management with Habitat, and a little bit about containers. So I'm Joshua Timberman. I work for Chef, and I've probably overheard something that you... Oh. That's the ViewSonic slide. Yeah. And I probably overheard something you said, and I posted it on Twitter. By trade, I'm a systems administrator and a software developer, and some people would say that I'm a DevOps. But Chef-style DevOps Kung Fu is a completely different talk. You can hear Adam Jacob give that talk at that link, and these slides will be available afterwards, so you have to remember D-E-T, yeah, whatever. So I'd like a little information about who I'm talking to so I know what kind of jokes to tell. Raise your hand if you're a systems administrator. No systems administrators? Software developers? Okay. Who's a business people? Who's running Docker in production? Okay, about half the room is brave. Okay. Anybody using Habitat yet? Checked it out? No? Okay, cool. So this will be some new information for you, hopefully. So something that probably isn't new to you is that software is complex. So who works with software? Everyone, right? Because everybody on the planet now works with software. And when you build modern applications for people to use, sometimes you have an architecture diagram that looks like that. Except now we're replacing OpenStack with Docker. It's cool. But everybody has an application, right? You get an app for that. You've got like 5 different websites you go to on your phone are trying to pop up and give you a mobile app and all that sort of thing. And all those applications have to run somewhere, right? So how do we actually run applications? I mean, there's so many different ways. We can manage them, we can deploy them, we can do all these things. We can go serverless. There's servers running somewhere. I mean, we could bike shed that all day, right? Just push it to Heroku. And that's Heroku's problem, and now we're serverless, and it's cool. I guess AWS Lambda is the cool thing now. I don't know. But I mean, we're at a Docker meetup, so we've got to talk about containers, right? So just run Docker, 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 right? We Docker run. We want to run it securely, so it's on 443, and we're going to run our Acme website container, right? But despite like those couple solutions, there's a couple of players out there. And I'll let you take a look at this slide while I drink some of this tasty beer. See, Chef's in here a couple places. I think Deis is on there too. I'm not sure. Yeah. But whatever you're doing, it's probably fine. Containers, right? So working with containers in your development environment is super easy. You just Docker run the thing, you Docker build your image, you Docker, and then you want to move that containerized application into production. And then suddenly we have to concern ourselves with a bunch of things like security and where do we host that container and how do these containers talk to each other and discover each other because they're all running on isolated local networks, and how do we make those available to others in the environment? Oh, how do we monitor that? Oops. Right? I mean, it worked fine in our dev environment. But what if you have multiple applications? You have to manage the application security settings for the container OS. You have to make sure that you're isolated away from whatever your development environment was and whatever development dependencies you've got crammed into the container. You have to make sure that those aren't going to pollute into your production environment where suddenly you have compilers running and then a botnet connects to your system and the Internet of Things takes over and compiles IRC nodes, and then all of a sudden you're serving up traffic for who knows what in who knows which countries. So you need to make sure that we've isolated that stuff away in packaging. And we need to have immutable infrastructure. But how do we build that immutable infrastructure that allows for application config changes? Right? Once it's running, how do we change the configuration? Oh, well, you just build a new Docker container because it's really fast, and then you deploy that. Well, now you've got an old image and a new image, and you have to, are you running the right one? How do we orchestrate the application launch order and the topology required? You've got 14 microservices right now, Bob, and you got 14 people coming to tell you that they're not talking together when they go into production. And finally, how do you build the containers with the minimum viable OS? I don't need cups and X11 and Java when all I have is a Python or a Node app. Though Node has somehow gotten itself into Rails, so I'm not sure how that works, but it also has Python in there somewhere as well. These are true stories, by the way. So how do we answer these questions? I mean, it's a talk about habitat, so I'm going to use that as the answer for all my carefully described problems. But modern applications, right? You've got a source repository, and then you build some sort of artifact. If it's a Java app, you've got a jar file. If it's a Rails app, you've got a directory that you've capistranoed out. If it's a Python app, you've got some pip and some requirements.txt, and you've got those packaged up in some way. And the sysadmins in your organization are probably like, yeah, put it in an RPM, and then we'll deploy that to production, right? Or now it's package that up as a Docker image, and we'll ship the Docker image as a container, except it also contains an OS that you didn't need for your app. Then you put that in an artifact repository like a Yum repo or Artifactory or some sort of thing like that, CPAN, Ruby Gems, whatever your app is. And then you deploy that out on your either bare metal, in your containers, on your cloud instances, VMs, whatever it is your infrastructure is running on, right? So you take your code from your local system and it ends up in production somehow, right? So you need something to build, deploy, and manage your application, and Habitat gives you those things. So when we ask the question, how do you decouple the application build from the final production-ready container, we provide with Habitat a DSL to describe your application build, which is called a plan.sh, and provide an isolated environment, which we call a studio, to build the application artifact, which is a Habitat package. So building packages in Habitat starts with a plan.sh. So it's just a shell script, and we're working on Windows support, so there'll be PowerShell scripts, but that's not a thing that's quite ready yet. It's in development. But here's a Bash shell script for building Redis. So we have a bunch of metadata about our package, like what the origin, the namespace of it is, the package name itself, which version we want, its license, and importantly where we download it, and what its SHA-256 checksum is, and then some other information about that package itself. And then we give it the instructions to build, which is make. Who's used make to build a software package before? Yeah, like everybody. So we just call whatever your make file is going to do, it's going to build that application. This could be, this could be your C app. This could be a thing that does a bunch of other stuff for installing Python for a Python app, or for doing Ruby and bundler and that sort of thing. Compare that to a Docker file. Some long lines, a lot of commands. They're all over the place. We've got some run up here, and then we've got run down here, and I don't know, Docker files never really made a whole lot of sense to me, because it is sort of like a shell script, but not really. It's like a YAML shell script, I don't know. And don't forget to do some configuration management in your Docker file too, right? We're going to create the directory where the data is going to live, and we're going to purge some build dependencies, because we don't want those build deps ending up in our final image and that sort of thing. So in Habitat, we do everything in a clean room called a studio. So it only has what you need. It starts out, it's bare minimal. We're using like it's kind of like just cherooting into an OS that has nothing in there except for shell. And then it has the Habitat binary that is used to do all the other work. It will install the dependencies that it needs for your application. So you define in your plan what dependencies you have. If you depend on glibc, if you need GCC, if you need make, if you need Ruby, you just define those dependencies in your plan, and then it will automatically install them for you. And it's safe by default. It's auditable. You know exactly what went in there because you told it what goes in there. And then everything that it stores about the package that it built is saved as a text file that you can examine. That's a lot easier than cracking open an RPM, and then there's a directory over here with some stuff and a directory over there with some stuff, and not all the metadata is there. And if you go get an RPM, you don't actually have the spec file necessarily. You have to get the source RPM, and it can be quite a mess. And studios are CI friendly, so you can build your packages for your application inside of Jenkins, Bamboo, TeamCity, whatever your CI solution may be. Then, once you've built your package, you upload your packages to the depot. So packages are stored in a depot. That's our artifact repository. It's a centralized location where you keep all of your application packages and any of its dependencies. We also have a publicly hosted one. You can run one yourself. All the code is available, and we have instructions on how to set that up for yourself. And then the depot also has what we call lightweight channels. And channels are just views, so we can say that this is the staging channel, this is the production channel, this is the pre-prod channel, this is the we're going live next week channel. And you can tell Habitat to install packages only from specific channels. The HAB binary is what does all the work for you. It follows pretty easy patterns of command line arguments and that sort of thing. It gives you some shortcuts that make it nicer to be able to work with the tool, where you say where things are HAB, noun, and verb, and they increase in specificity. So you could say HAB install acme/redis, or HAB install acme/redis, and then give it a URL to your internal package depot and that sort of thing. So if we see the HAB package install at the top there, installs core Redis, it downloads Redis, then it uses the glibc that it already had, it uses Linux headers that it already had, and then it installs core Redis. Then once we have that installed, we have in the /hab directory a packages directory that has all the packages, and they're separated by core/Redis, the version number, and then the specific release. So in Habitat, you have a fully qualified identifier for your package, so you know exactly at that point in time, here is this package, and in the deps file and in the tdeps file, it will have similar strings for each of the other dependencies. So see, we've got glibc 2.22, 2016-06, etc. That is actually what is in the deps file, and any transitive dependencies would be in the tdeps file. So you know exactly which specific packages were used at which point in time for building your application. Who's ever run into an issue where you've upgraded your application code and then the distribution underneath you changed the version of Ruby, Python, Java, etc., right? Like everybody's run into that problem. It's dependency management hell. And when you build your packages with Habitat, you get away from that because you get the specific versions and you keep all those versions on the artifact repository so that you can download them for that point in time. If you need to roll back or deploy an older version, then you would get whatever those dependencies are. You don't have to muck around with, oh, well, Red Hat upgraded the version of Python. Oh, sorry, Red Hat doesn't do that. But theoretically, Red Hat updated the version of Python. So now you have to go and update your Python code or try and figure out how to make an older version work with the older version, and like you get into this mismanagement nightmare. Yeah.
So core Redis at the top of this thing, is that the plan? What is that reference?
Okay, so core Redis is the name of the package. So core is an origin, and I'm going to go through an example of this in more detail. But core is the origin, it's the namespace for that package. So it could be Acme, it could be Deis, it could be Docker / whatever package, right? So the origin is going to be usually like a company name, an organization name, that kind of thing. And then Redis it's Redis, right? We have glibc, we have Linux headers with.
Points to the output of the running of a plan, or
No, this is like yum install Redis. This is have package install core Redis. So it's just a slightly different command for basically doing the same thing. Does that make sense?
sure, but the thing on the right is referencing all of these other Redis and glibc and headers.
Oh, so what it did was it in the installing core Redis part, it talked to the public depot and said, I want core Redis. Give me the latest version.
What
And
is the thing within the depot that you're asking for?
the depot has the metadata that's from these deps and tdeps. So the depot has this in the API.
It has the output of running the plan, right?
Yeah.
Thank you.
Yeah. All right. So we could also do post-processing of packages. We can export Habitat packages to other packaging types, particularly for container use. So I can use my plan to build my package, and then I have a file on my disk, the artifact of that package, and then I can say build a Docker container with that. And there's a hab package export command for Docker, for ACI, for Mesosphere, and we're working on building more of those. So configuration is important. How do you build immutable infrastructure but allow last mile application config changes? Well, with Habitat, you ship the config alongside in an immutable application artifact, and then you provide a supervisor that dynamically updates that config based on environment or service discovery. So the environment configuration is information that the supervisor has about it, and you can inject your own environment. So you're running in a shell, right? So you can inject an environment variable into the shell for your package that is going to allow it to change the configuration option. And I'll show an example of that. We do this 12-factor style. So if you've read 12factor.net, they talk about using environment-based configuration. So we took that as a core principle with being able to do configuration in Habitat. And then it's externally enforced. So that allows us to apply configuration externally in a way that is composable. So we can use a config file locally, and we can use a that we're going to read into the environment. We could also inject the config files. That gives us a little more flexibility than the environment. We have a universal location, so every package has a service directory when it's running. If it's a package that runs software, glibc doesn't run a service, but Redis does, and Redis has a service directory that is going to have a place where the Habitat configuration can be injected, and then we can externally manage that. So how do we orchestrate the application launch order and our topology that's required? With Habitat, we provide config-aware autonomous self-organizing peers, or supervisors, with built-in topologies for clustering strategies. So what does that mean? We've got supervisors that run services that install whatever their service is and its dependencies automatically. They do that hab install automatically for you, and then they keep things running. If the service dies, it restarts it. Who's familiar with Runit or Daemon tools? Who's used a cookbook that I wrote that used Runit and you're like, ah! I see a few hands. So it behaves similar to that, where service dies, restart it. Now you might have to do some kind of exponential backoff to prevent the system from getting overloaded, but you probably had to do that with your application anyway if you have something that behaves improperly and that sort of thing. And then the supervisor manages the configuration. When it starts up, it reads in the config from Habitat, and it renders a template for whatever config files you've created. So if you've got a application that uses a YAML file for config, you would write your YAML file as a template, and then you'd use variables for Habitat to be able to inject that from its configuration, where it's just going to be those variables. Each of these supervisors that's running on a network forms a ring. So they have, I believe, we did some rewrite of this recently, but I believe it's still a SWIM-based protocol that does the gossip, and they talk to each other. And then that ring has data about all the services that are running, and we can query that from the local system or across the network if we've exposed that, and you can use this for debugging, you can use this for health checks, and you can use this to determine if the database has a leader that is there, and we can create replicas of that, or we can have a web application proxy in front of our web app, and we can use that REST API to get that configuration data. Each of the supervisors, or the hab supervisor, is aware of topologies, and this allows us to have different kinds of topologies for deploying applications. So we have the leader topology, which is I have a single leader that is going to have replicas that are going to talk to the leader and get whatever they need. Think like database servers and any replicas that they might have. We have initializers, where you have one system that needs to start up, and then all the other systems that start up need to connect to it. And then we have standalone topologies, which are independent services that are running, but it's still useful to have them be able to talk together. And then the supervisor provides what we call update strategies. So these are topology aware, and it tracks a view in the depot. So remember I mentioned we have these different channels or in our depot that are views that we can say this application is going to run for production, so we're going to watch all changes in production. So when we upload a new package, we don't put it into the production view automatically. We might put it into a staging view or a development view, and then allow our testing to happen. And then once it's tested, add it to the view for production, and then all the systems that are out there that are running these supervisors would see that change, download the new package, and update it. Now, right now, the only topology we have is all at once, but we're also working on supporting a one at a time update strategy where you can say, okay, we're going to update web server 1. Okay, everything's cool. Update web server 2. Everything's cool. Update web server 3. And we can know that those are done and ready because they have this ring that they can talk to each other and know that the service is up and running now, and we can move on to the next one. They automatically self-elect and self-organize. So we're doing that through the gossip layer. All right, so we want to run containers, right? And we want our containers to have the minimum viable OS because we don't want a bunch of bloat from all the other things that come with the Linux distribution. So how do we build our containers with the minimum viable OS? Well, we allow applications to declare only the runtime dependencies, and we resolve those dependencies from the application to the infrastructure. So what that means is, in the current world, I'd say, we have an operating system and a bunch of libraries, right? You've got a bunch of stuff you've installed. You've installed Red Hat, you've installed Ubuntu, you've installed Amazon Linux, whatever it is that you have running some system with an OS. And it's got a bunch of things in it that came from the vendor. Most of that you probably don't actually need. You certainly don't need LSB base and whatever CUPS is going to be doing on your servers, right? But it's there anyway. Thank you, standards. So once you have the OS and the libraries, then you have your application with the application libraries and any configuration that you're going to have. Does this look familiar to anybody? Okay. With Habitat, we start with the concerns of the application, not with the operating system. So Habitat only packages your application and the dependencies that you have. And you can have dependencies on other things that other people have created. So if I create a package for Redis and you want to use my package for Redis for your application and depend on it, then you can do that. Or if you need to use libpng, you can. If there's a package for libpng that somebody's provided, then you can use that for rendering your portable network graphics. And then you can have those all bundled up. Your application is going to have its own package, and then it would install any of those dependencies separately. And then that gives you only what you need when you go to package when you do that package export of your Docker container. Then you only have what it was that you specifically depended on. You don't have the cruft of the entire operating system coming along with it. So where do you run Habitat? Yes, question.
I'm curious what you guys run for that underlying operating system. Is it sort of Alpine or?
Yes.
Okay.
So the underlying operating system is Alpine. For the default way that we're doing things with Habitat. You can start from any kind of 64-bit Linux and build your packages from there. We're just using Alpine for our default, like the dev shell that we use for building all of our packages. And we've tested it. The package is built on Alpine Linux, running whatever the latest is. At least when I was working with it a couple months ago, those packages would work on Red Hat 6, Ubuntu 14, Amazon Linux, Arch Linux. They'll run anywhere that you have Linux because you don't depend on the rest of the operating system.
So as I understand it, are you guys developing your own sort of package manager?
Yeah, so Habitat is a package manager.
Okay.
And I'm gonna go through an example and talk about what each of the components are so you can see how it actually works.
A little more than that, though, because it also has a deployment strategy.
Right, and I'll talk about that. I've got a whole example. So, where do you run Habitat? So there's a couple places. First, you run Habitat on your workstation or your CI build node, right? You install Habitat on your workstation, and then you use it to enter a studio. And a studio is just we use a Docker container. It could be a chrooted environment on Linux. A studio is a component of Habitat that it fires up a shell and drops you in there with basically nothing but Habitat itself. And then from there, it has you've given it whatever your plan is, and then you tell it to build. So I'll show you how that works. Then you also run Habitat on just enough operating system in your containers on VMs, a cloud instance, Docker containers, etc. You would install Habitat out on those, and then you do hab install my application. It pulls it from the depot, and then it runs that service. So to summarize, we have an isolated immutable package that Habitat has created that's configurable through external methods. We can inject our configuration with environment variables or config files. And we have a supervisor that gives us an API for monitoring the health and the configuration of all the members of, or all the applications that are running in our network. And then when we build our packages, we're building them from source because we're not concerning ourselves with whatever the operating system has provided for us. We're bringing in any dependencies that we have. That way we have complete control over it. It makes it auditable, and security folks like that, I hear. And then we can run that. It's a common package that we can deploy on any 64-bit Linux. It does need kernel 2.6.32, but oh my goodness, if you're running a kernel that old, somebody save you. And it has a runtime independence, so it can run inside of containers, it can run in VMs, it can run on bare metal hardware. So what we say is that Habitat is automation that travels with the application. We've ported existing and cloud-native software. We've ported legacy applications, and there's no external entities required to do so. We don't have to do any hijinks or tricks other than what we'd normally do to build packages for our software. One of the cool things about Habitat is it's free and open source under the Apache license, like like all of Chef's open source projects. It's Apache licensed. And it's available on GitHub. So before we get to the questions, let's look at an example. So I have a plan here for a package called OmniTruck. Who has installed Chef on a computer? A few people. You've probably used OmniTruck. It's a little API service that translates a bunch of arguments on a URL call to a link to download from our package repository. So OmniTruck is the name of my application. The package origin is chef-es. That's the team I'm on, the engineering services team at Chef. I've got a couple things that are undefined because we're going to calculate them later. But the upstream URL, where we're going to get the source code, is on GitHub. The maintainer, a description, and a license for the software itself. Now, in order to build this package, I need to have core utils, GCC, make, and git. Because this is a Ruby application, and Ruby applications are notorious for having Ruby gems that have C native extensions. So I need to be able to compile those native extensions. My upstream URL is on GitHub, and we're going to do some Git things from that to do these calculations for those things that are undefined. Now the runtime dependencies, we need to have bundler, because when we build this package, we're going to do a bundle install into the directory that's going to get packaged up and run, and then we do have a couple that are executed inside the environment of bundler, so we need to have that available. We need to have CA certs because SSL is important. We need glibc, we need core utils, and we need a specific version of Ruby. Now note that these other package dependencies don't have a version specified. We're just going to get whatever the latest version is. God help us. But this one, we need specifically core Ruby 2.3.1. I could also say / and then one of those releases, the 2016 timestamp on there if I needed to get that specific as to which version of Ruby. So if I had a security vulnerability in Ruby and had to recompile Ruby, and then I would need to update and make sure that when I install Ruby, I'm going to get the latest version, that's the latest release, right? So I'd put in that if I needed it. Then the application is going to run as the HAB user. That's our convention. We have to have that user available. We have a lib directory, and we're going to expose port 80 so that the system will be able to listen on that. When we do a Docker export, it will automatically have port 80 available for Docker to run, or to be available. Then what we have in a plan is these callbacks. Callbacks are functions that you can override in your plan. There's a bunch of them defined already in Habitat's build script that runs this plan and builds the package. But I've overridden the verify one to say, I'm going to calculate my package version. I'm going to give it a directory name and a prefix. And these are all calculated on the fly whenever I build the package. Similarly, I have a prepare where I'm going to tar up the directory and I'm going to exclude some stuff that isn't needed for the actual application to run, right? Who's got some stuff in their application that isn't actually necessary for it to run in prod? You know, you've got like a make file, you've got a gem file, like that sort of stuff, right? Or maybe you need the gem file or the gemfile.lock, right? So we exclude those and then we extract that out to a directory on the system, in the build environment. Then the actual build, we're going to set some stuff up for Bundler to be able to find its friends, and then we do a bundle install. So it's pretty straightforward. If you've built a Ruby application before, you've probably seen similar things to this. We're doing a little bit of hijinks because we're running this inside of a studio that doesn't have a user lib Ruby. It doesn't have anything like that because it's a bare minimal container that has nothing in it that you don't need for the application. So we need to tell it where everything is because we're using our own packaged versions from Habitat. Then when we do the install itself, we're going to copy this over to a static directory because it's a static application. We're going to do some hijinks because every single script under a Ruby package assumes that you have user bin env, which we don't, because we're going to use it from because we've got in Habitat we don't have a user bin env. We've got a core utils something bin env. And then these other ones we're not going to download or unpack because the download is actually, or this is actually going to run from the directory that we're in. So let's see how this works.
Is this an actual shell script? Is it like something just sourcing this and then running stuff?
Uh-huh. Studio. So I'm going to go into a studio. So it creates a /hab/studio/src. It imports the core origins secret key. If you're using a different origin like Acme or Deis or whatever your organization name is, then you'd create a key and import that. The Habitat tutorial will show you how to go through all that stuff. And then we enter the studio, we're in the /src directory. Now this is the OmniTruck application. And here's my plan. Yep. It's too smart for its own good. So it just needs the directory of where the plan is located. So what it's doing is it's providing some nice output. We needed core utils as a dependency for our build. So it's downloading and installing core utils. We also need GCC and Linux headers, and we have transitive dependencies and so on. So it downloads and installs all of that stuff. Needs Perl. I don't know why, but this is how you end up with a Linux distribution. I swear there isn't cups in here though. We haven't got that far. So the actual build does some stuff where it sets a prefix, right? Like who's done configure -- prefix and changed the thing, right? Similar kind of deal here. We have an LD run path, so we know where our shared libraries are. We have some C flags, so we can find our header files, because we're going to compile some native extensions, probably, because there's going to be some Ruby gem somewhere in our gem file that's going to do that, right? Then we do the build. Whoops. We do bundler. Don't run bundler as root, but we're going to do it anyway because we're cool. We've done a bundle install. Then we set those shebangs for Ruby. And then we have some configuration and some service management scripts. We have a run hook that tells Habitat how we're going to run the application. We create a manifest and build some package metadata. We use Blake2B for our hash checksums of all the files, and then we generate the package artifact with tar, and then we sign that artifact, and we have a heart. It's a Habitat artifact. So once we've signed that, we have built our package. We have an artifact here, and I can do a hab package export docker core omnitruck, and now we're going to use hab package export docker uses our hab package dockerize. I didn't have that installed because I didn't need that in my studio. Oh, you wanted to use that now? Okay, now I'll go and install it for you, and it will get everything that it needs in order to run dockerize. So it generates and builds its own Docker file. It's sending it to the Docker daemon. And if I go, here's the one that's creating. I'll make that bigger. Core omnitruck. So if I do a, oops. No, not code. Oh, because I bet we'll just do this. By default, we are running this application under Unicorn with a domain socket. So this starts up the container. Butterfly is the library that we use for our gossip protocol. So it starts up that on port 9638. It starts up the REST API on 9631. And then it updates the config files. Oops. This we'll get to in a second. So polar config and unicorn.rb are configuration files for Omnitruck. So we've updated those, and then it removes the previous version because it's a static app. We're going to blow away whatever was out there in the service directory, and we're going to deploy the new version. This is keeping in line with the notion of immutable infrastructure and immutable artifacts, right? We're not touching the code that was in the package. We're going to deploy that to a separate directory on the system. It adds a little bit overhead, like maybe a couple seconds for however long it took to run that, but in the end, we're not polluting our deployed artifact with any other configuration. We take care of those config files, and then we have what's called an init hook. And that init hook is what's doing all this work here, and it's what is seeding the Omnitruck application with information from our package repository that has all the chef packages. So we've got supermarket and sync and chef DK and reporting, like all these packages that we publish OmniTruck sits in front of those, so we need to have that data. You could also do something like a rake DB migrate. You could do something that sets up other schemas for your application. Anything that your application needs to do before it actually starts running, you would do in your init hook. And then we run the app, and Unicorn is listening. Oh, I can't suspend it because it's running in Docker directly. So let's go into a bash. So 797 was that version that was calculated automatically in the plan, right? If you had a version 3.2.1 or whatever, that would be whatever the version of your application or the package you're working with is. So if we go in here, we can see the dependencies. We can see the transitive dependencies.
What are transitive dependencies?
Transitive dependencies are the dependencies of your dependencies. And Habitat will resolve all of those. So we need bundler. Bundler needs Ruby. Ruby needs libyaml and zlib and
Why is Ruby in Boulder?
because we directly depended on Ruby.
Like
TDEPS is everything. Yeah, TDEPS is kind of like your lock file. It's everything that you needed, including whatever was in your runtime deps. So the deps is just the runtime deps. It does not have your build deps. Build deps are in the build deps file.
Those got whacked though, right before we built our.
Correct. So if we look in, right, so we shouldn't have GCC or make, right? I don't see I see GCC libs, but I don't have GCC. I don't have git, right? So those were not installed in the package or in the container, or with the package or in the container. So let's see, where was I? So in our hooks directory, this is part of Habitat where we've got different hooks for different events for managing the service. This run script is a shell script that gets executed by Habitat's supervisor when it runs. So earlier we saw it started it up, right? It had those unicorn workers running. It ran this script. This script is a handlebars template with the double curly braces for any variables we're going to pass in. So we have package variables that come from the Habitat package itself. We have configuration variables that come from the config file. And those are going to get rendered in the service directory once we've started the application. Now we haven't started the, did we start the application? Yeah. I don't think I started in this one. So I'll just So after we start it up, we get these other things created. Remember we had the config data, the config.toml. We use toml for the data file type instead of ini or YAML or JSON. So we're using toml for that because it's a little nicer to work with. The data directory, we have a files directory, hooks, the run script, the static directory. Off on the end there is of our directory. Question?
Yeah, I was actually curious. So when you do that have run that you did, is that similar to a Docker run?
I didn't do a hab run.
Oh, what was that last command that you did that spit out all that output in your other tab?
Hab start?
Hab start. Is that similar to a Docker run? Or
Kinda. So what the Docker run command that I did is it runs hab start.
oh, okay.
And I can do hab start bash. Oops, I guess that's not where it is. But it does a hab start on the package when you start up a Docker container. So if I do if I just do that, then it's going to do the moral equivalent of a hab start. Except the port is listening, so it's not. I'm sorry? Yeah, this is so Habitat is the entry. Habitat supervisor is the entry point into Docker, right? So this would be PID 1. Um, okay.
When you were talking about the shell script that is run by the supervisor, where is the supervisor? Is it Alpine Linux and doesn't have bash?
Is that supervisor custom built, or is it based off of like Run or something?
So I'll repeat the question since since we're recording. So the first question was, what is the? Sorry, can you repeat? It was the.
Yeah. Where is the supervisor?
Oh, where is the supervisor? So the supervisor is a package that is installed when you do the hab package export Docker. It knows that it needs to have a supervisor to run inside that Docker container. That's going to be the entry point for PID 1. The other question
Is that supervisor like custom code, or is it derived off of like?
is hab supervisor custom code? Yes, it is. It's basically a port of Runit to Habitat. Habitat is written in Rust, so we rewrote Runit in Rust, essentially. It's not exactly Runit. It's got some other stuff, but it behaves similarly. And the entry point is the same. So it's here our PID 1 is going to be bash, but over here, over here when I run this, PID 1 is going to be hab sup.
The last question was, so the supervisor knows how to execute a bash script?
Does the supervisor know how to execute a bash script? Yes. So what the supervisor does when it starts up, it goes through the hooks. It looks at the init hook, and the init hook is a shell script. So it executes that shell script, and it's going to do all of these things in order to initialize the application. Your application might not have an initialization script. It might have one more complicated than this. It might be simpler, right? It depends on what your application is. So if you think about it, what do I need to do in order to get my application to start? The init hook would have that. The supervisor automatically runs that script. It does have to be shell. We strongly recommend bash. I don't think that it works with like KSH, but if you have like binsh, then it might work as long as you're adhering to whatever limitations your binsh has. But just use bash and you'll be fine. Also, we provide a bash package that you can use that has everything in the whatever the latest version of bash was when we built that package. Yeah, question?
Are the supervisors partition tolerant?
Are the supervisors partition tolerant? I believe so. I'm not sure on the exact implementation in the code about that, but that'd be a superb question to ask in our Habitat community Slack. Let's see, the run hook. So when we run the hab supervisor, it executes the run hook. Now, the application that we're going to run must run in the foreground. If it forks to the background, you're going to have a bad time, because it will think that it exited and try and restart it. It's just like running under any other kind of supervision suite, like daemon tools, run it, and so on. So it needs to run in the foreground. That's generally not an issue with like web applications. Most of them will run in the foreground. So this is, in this case, we're running Unicorn. We give it this config app environment, the static path where the config file is, and so on. The Unicorn config is pretty small. So this has been populated from the template. So the configuration has those values, and it rendered those with the defaults. Where do those defaults come from? That's a good question that nobody asked that I was just going to answer anyway. We have a file called a default.toml. And the default.toml is the defaults configurations for your application. And it's a TOML file, so you can use TOML tables, like we've got unicorn and polar, and all these values get fed into and can be rendered through any of the things that are templates in Habitat, which include all of the hooks. So all the hook scripts, the init script, the run script, the config files are all handlebars templates, so they can all use this data, as long as they use that CFG dot prefix. So if we look at this, we got the timeout 60, came from unicorn timeout, preload app false, worker process is 8, and so on. If we look at the template, config.unicorn.listen, right? Pretty easy to follow. Any other questions? Yeah.
What is a TOML file?
What is a TOML file? That is a good question. It's a markup language created by Tom, who I believe used to work at GitHub, and he wanted something that was easier to read and understand than YAML or JSON, but a little more expressive than any. So he created it. It is. That needs to go away. You can't see it because it's on my screen. TOML. Stop. Tom's obvious minimal language. Yep, it's obvious, right? I mean, everybody's used an any file of some sort. But it gives you some more things like key value pairs and arrays and that sort of thing. Any other questions? Not with the Habitat stuff. You could use you could have TOML render into a YAML file and then have your YAML file feed into your config file, but I think you would probably be better off just using the TOML and eschewing the YAML part. Yeah, question.
So, you know, some of the, how is Habitat designed to work with some of the other orchestrators like Kubernetes or Mesos or anything like that, which have some sense of, you know, config management, service discovery, that sort of thing? What's the recommended, like, path?
I don't have a specific recommendation. I haven't worked with any of those, so I'm lacking experience on that. So another great question to ask in the community Slack. We do have a number of people that are actively working with Kubernetes and Mesosphere and making sure that those integrations work well with Habitat, and we can eschew our service discovery stuff for their service discovery stuff or whatever. But like I said, I haven't worked with it, so I'm not familiar with those.
If you would, can I go through it? How do you do this without Docker?
How would I do this without Docker? That's a great question. So let me go to my build or my source directory. So I got my application source code, right? And I'm going to build this one because it's faster than the other one. So at this point, what I have is an artifact. This /src/result/cord, which is the origin, omnitruck unicorn proxy, which is the name of the package, the version, etc., blah, 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 dot heart. This file is on disk. From here, I have that file on my local system. So when I'm inside of a studio, I do a bind mount of my local directory, whatever the current directory is the /src directory in the container that I'm working in, inside my studio. So when I build that heart file, it's now available on the host operating system, my development workstation. I can take this heart file from here and do a hab package upload. I can upload this to the depot. The Habitat organization's hosted depot. Yes, it's a project by Chef, but the Habitat organization is all on its own there. It's open source, etc. But the public depot I could upload to there. I could give it a URL to an internal depot if I was running my own. I would have to upload any of the dependencies that my application has. But one of the things that the hab package export can export is a tarball of all the other dependencies as well. It does that to do the Docker container, and it also does that for if you wanted to do an ACI or a Mesosphere export. So we also create when we're in a studio, we have a /hab/cache/src that has all of the source code for our application. Yeah, question?
So the studio itself, like, is it a container of a different kind? Is it a Docker container? Like, what is the studio?
The studio itself.
So I'm on my deck, and I enter a studio. So where am I relative to the rest of my file system on my deck?
So where am I when I enter a studio? This is on a Mac, and I have Docker for Mac running, and it created a Docker container.
Okay.
So if I do oops, not from there.
Do you use Rocket?
I don't think we support Rocket right now. But if I do a Docker PS, I can see I have a Hab Studio running. If you run this on Linux, you get a chroot. It just chroots it off into directory. Hab Studio, I'm not going to increase the font size, but this is a shell script that does all the things for your studio. 1,000 lines of shell. The thing that builds the plans.
And this is under Apache, so I can go look at this later.
Oh yeah. I got a link for you in just a second. The thing that builds the plans. So when I run the build script, that's this script. It's the hab plan build, and it has all this metadata that it sets up and a bunch of functions. And we have internal functions that are only used for this. And we have some, where's a callback? Here we go, do download. So do default download, that's going to be a download file, right? It's all shell scripts. All shell scripts all the way down, because that's actually what builds the internet. All right. So I've got URLs here, if I can find my cursor.
Were you gonna bring up that we were in the process of starting that without Docker?
Oh, right. Yes. Okay. Let's go back to starting this without Docker. So, is it core OmniTruck? So I mean, it's contrived, right? Because I'm already in Docker. But let's just ignore that. If I'm on a system, like I start up an EC2 node, and I install the hab binary, then I can do and I've uploaded this package to the depot, then I can do a hab start core OmniTruck unicorn proxy. It will download that from the depot. It will also install the hab supervisor and all the other dependencies of the supervisor and of the proxy software, which is Nginx, and then it will start it up.
Can I
we have a static binary. Somebody, and it's all open source. Somebody could create a HAB package for distributions if they wanted, but it's just a static binary that you use to install HAB itself. Where is that? Support. No, Linux. I'm going to go to GitHub. So we have an install.sh script so that you can curl your bash and like it. And this is actually pulled from the Omnitruck install.sh script, a lot of it, but the core of it is down here. The do install. Let's see, hold on. So we publish our package, or we publish the static binary to bin tray here, and then that's available to download. It uses that URL with this do download function that goes and retrieves it, and then it goes in there, it extracts the HAB file, and then does the do install step, which is on OS X, it just drops off HAB in user local bin. On Linux, it uses the statically compiled HAB binary to install core HAB. So it will get the non-statically compiled HAB package installed, and then it handles creating a bin link in /bin for you to be able to use Habitat from there. You can also download the statically compiled HAB binary on a local system, build an image, an AMI of that, and then deploy and do whatever you like with that. Yeah, question?
I'm really interested, you're the first, and I'm kind of curious, how is that going for you guys, and how was kind of developing that sort of newer ecosystem?
So the question is, how is Rust going? We're one of the first companies using it. We love it. It's been fantastic. So all of Habitat is written in Rust. The server, the various services. We're working on a build service where you can publish your plan somewhere, and then the build service would build packages for you and automatically put them in the depot. All that stuff is Rust. The HAB binary itself is Rust. We've had a lot of success with it. It's wonderfully safe systems language. So it gives us a lot of system safety that we need for writing system software that we just weren't getting from other languages. Adoption internally is going pretty well. Like anybody else, we try and hire really smart people that can learn things quickly, and we've got people that are learning Rust at a pretty rapid pace. But Rust is a very complex language. It is not small, and it is not trivial. It's not something that most people pick up in like an afternoon of reading, a couple blog posts. It does take some time. I don't know what a ramp up time is, but there's definitely a learning curve there as compared to other languages. But we think that the trade-offs for that are paying off quite well. We also use Rust for the Chef Automate software has a client a CLI that is written in Rust as well. So we're using it there also. Other questions?
What was the motivation to use Shell with kind of DSL versus just picking something else?
Yes. What is the motivation for using Shell? Because it's everywhere. That's really the basis. We looked at a lot of different build systems and a lot of different ways that different things built the software distributions for various Linux distros, and you've got a mix of Python and Perl and Haskell if you're using Nixos, and sometimes you think, well, I want a little bit more of an abstraction away from, you know, just shell code. I want to be able to do more programming things. But at the end of the day, you're building your application. You don't actually probably need those abstractions for building your apps. Some people do, and you can totally write a tool that you call from your plan that does all the other complicated stuff. See also a make file, right? You could have a rake file. You could use anything you like that is going to call other things that you want to run if that's what your applications need, or if what your applications already have. Yeah.
You just put those in your build decks.
Yeah, so would you put those in your build deps? Yes, you would put any of those other software tools that you needed, you'd put those in your build deps. The Habitat project provides a core origin that has a bunch of core things that you would probably need for building most applications. We're trying to make that core origin provide the most basic stuff for everything. You know, you need zlib and Ruby and PNG, and eventually somebody will compile X11, and I hope it's not me. It almost was, but I escaped. It was cool. OpenSSL and so on. You need all these core libraries for just about every kind of application. So we provide those under the core origin. Yeah.
A lot of people cite Docker as really excellent for development workflow, and a lot of that comes from the layers approach. So it's kind of like a dependency sharing with the file system connections.
Mm-hmm.
Does Habitat have like an analogy for that, where it can save build time, or is it not really for that use case?
Question being, does Habitat have an analogy to Docker's layers? No. What you're doing is you're building an artifact that you could then put into a Docker with and make use of those layers if that's what you wanted to do.
And then like you're building the Docker containers, but then you can't like use the union file system to share dependencies, because wouldn't it be like non-deterministic?
I'm not sure. I'm not that familiar with how Docker's internals work.
Okay.
So I don't know how the union file system plays into that. But the way that you would share dependencies between applications is you upload them to the depot, or you can export a Docker container, or you can export a tarball. So I could say, where's my shell? So, oops. So I could do hab package export tar and then my package name, and it will use all the local packages that were required, and then what it's going to do is spit out this is the first time I've actually run the tar export, so let's see what happens. This is exciting. Looks like it's creating a symlink thing. Okay, where'd that end up? Ah, then we have this big tar.gz. So it builds a list of all the dependencies. When you use the tar export, it builds a list of all the dependencies for your application, and then it tars up everything in the hab packages core of each of those dependencies. Does that make sense? And then you can ship that tarball off anywhere else you want. Other questions?
This feels a lot like NixOS at the container level. I don't know if you're familiar with that at all, but was there a lot of influence from there, like design cues?
That's a great question. Is there influence from NixOS? And the answer is yes. So as we were building the plan build and the ways that we approach the dependencies and making sure that we have an immutable package. I mean, I'm root. I can go in and change a package, right? Like it's not immutable, but for all intensive purposes, or intensive porpoises, a lot of that influence came from Nix. We also got some influence from Arch Linux. If you look at a plan.sh and you compare that to one of Arch Linux's package build definitions, they look very similar. Yeah, there's an existing body of work out there. The reason why we reinvented some of it was because we had specific concerns about the ways that we wanted to be able to run services and deploy applications with having a gossip layer and having a supervised service that takes care of itself, the restarts, that has these health checks and so on. Any other questions? Great, thank you.